So guys, we're gonna continue the next topic. It's all about 7.7, and it's gonna be separation of variables, and we do from general solution to particular solution. The 7.6 is a general solution. So for a particular solution, we are solving in terms of variable c, right? We're gonna solve the variable c or the constant. So we have, and this is second to the last topic of chapter 7. So by tomorrow we're gonna discuss 7.8, and then Thursday we're gonna do the next chapter, 8.1. There are 12 topics for chapter 8, so I'm sure before the end of March we can finish, so we can have full review for the AP. So now before we do this particular solution, we don't care about the graph. Okay, we don't care about the graph because mostly for this particular solution in the actual AP doesn't need or doesn't require graph. It's just the way you do it, you solve it, and free response questions or even in multiple choice you need to solve it. Okay, so find the solution to the differential equation dy dx is equal to x and y, product of x and y square with initial condition. So we have now the initial condition that if x is 1, the function is also 1. Okay, so for this initial condition, this implies that x equals 1 and then y is equal to 1. That's what it means. Okay, so first is we're gonna copy the given dy dx is equal to x times y and then square. We're gonna take right away the derivative of that. Instead, you're gonna rewrite this one. So what is x times y to the power of 2? This means this is simply written, we can rewrite this as x square y square. Get me? Is this clear? Okay, and then we now say we can now separate the variable separable. So how to do this one is we gather the y with dy and the x with dx. Okay, so we're gonna say dy over y square is equal to x square dx. Okay, so we separated already, right? Then after that we're gonna integrate, so put integral sign. So but this one we cannot do right away integration because this is at bottom, so what we do is to bring it up, right? The y to the power of 2. So rewriting this gives now y to the power of negative 2 dy. So it's easy for us to do antiderivative, right? Yeah, guys? Okay, so equals the integral of x squared dx. So can you now take the antiderivative of y to the power of negative 2? The power increases by 1, and the new power is the denominator. So that means negative 2 plus 1. What is negative 2 plus 1? Negative 1. So this is y to the power of negative 1 over negative 1. Is this clear, guys? And next, we have equals. So x to the power of 3 over 3. Okay, then plus the constant. So what to do? Bring down first the y. Okay, so this means negative 1 over y is equal to x cubed over 3 plus the constant. Now, what is the initial condition? What is the initial condition given? X equals 1 and y equals 1. So you're gonna plug in now. You're gonna plug in. So 1, negative 1 over 1. So right here, it's gonna be negative 1. Do I have to show you plugging in? No need, I think, right? Can we do mental math right away? If y is 1, so maybe you'll be confused, so I'll just write negative 1 over 1 is equal to 1 to the power of 3 over 3 plus the constant. Is that clear, guys? Okay, so which means, can I just continue right here? So negative 1 is equal to 1/3 plus c, right? And then what to do this with this 1/3? We subtract both sides by 1/3. So this means negative 1 minus 1/3 is equal to c. So we now say negative 3 minus 1 all over 3 is equal to the constant. So the constant now is negative 4/3. Okay? The constant is negative 4/3. So that's the C. So where to plug in this? Constant. So I just put this as a cloud. Okay? So remember, we have to do it here, right? So what we do now, I'll just copy down from negative 1 over y is equal to x cubed over 3, and then minus, what's the value of c? Negative 4/3. So minus 4/3. Okay, but we are not done yet. We're not done yet. So what to do? This is negative, so can we multiply both sides by negative? So if we multiply both sides by negative, this is now 1 over y is equal to negative x cubed over 3 plus 4/3. Now, they have the same denominator, so can we combine together this one? But we can rewrite, if you have this, you can rewrite as 1 over y is equal to, I can also write this as 4 minus x cubed over 3. But we are solving for the value of y. But it's gonna be on the left side, 1 over y. So what we do, can you still recall what we were doing yesterday? We're gonna reciprocate both sides. Okay, we reciprocate both sides. If we reciprocate this one, so we have y is equal to, with this becomes now 3 over 4 minus x cubed. And this is our particular solution. And of course, if you wish to graph this one, remember what is the initial condition? X equals 1, y equals 1. Particularly this point, right? This point. Now look at this. That means what is y? Positive. Okay, this one at the value 1, 1. So this is the point right here. So can you trace the slope fields? What do you think is the slope fields? Of course, if you graph this one, we are not after of the negative since the value of y is positive. So we do only the graph on top. Clear, guys? So the graph looks this way. If we trace this one, look at this. Then down, okay? So that means this is gonna be like this. Okay? It's the graph. More or less, the graph looks this way. Never mind graphing the bottom, because this is what? What is this function? This is rational function.
Yeah. That's correct.
So this is one. So after that, you can make copies on this one. Double-sided. Make it double-sided.
On that one? You want me to do it right now?
It's better for this first.
I'm gonna be behind for 2 months. And
Make
this
it
one day.
double-sided. And then staple. 28 copies.
We are not. We are behind.
Thank you, David.
Thank you, David.
Hey, David.
David, not 28 because that's AP pre-cal, right? I need 68.
68?
Yeah, because that's for period 1, period 3, and period 6. So 68. Okay. Is this clear, guys? Again, we're gonna have another graph right here because this is rational. But because y is positive, this is the value of y, right? If x is 1, y is 1, and it's positive. That's why I have this particular point. So that means the value of y is positive. So we are only after the graph of a positive value, excluding the negative. If we trace this one, this goes that way, right? Because this is rational, but we are not after of the graph of the negative. Do you get me, guys? As I said, we are not after of the graph of the negative side. Okay, we exclude that one. So, shall we move on to number 2? Are you clear? With number 1?
The first one.
Is number 1 clear, guys?
And afterwards,
Okay.
the tendencies. I mean, I guess those first 4 matches are the closest to non-bleed.
Why can't we have a class on John Cena's
Yeah, literally just matches, just put matches. Like no points or nothing.
So, moving on to number 2. What is the condition right here? What do you mean by this? F of 2 equals 1. That means x equals 2 and then y equals 1, right? So what is y? Positive or negative? What is y? Again, guys, look at this. Look at this. What is y? Positive or negative? Therefore, if we graph this one, we only have to graph the positive, okay, not the negative. Same as or similar as number 1, our concern is to graph only the positive because the value of y is positive. So next, we're gonna have dy over dx, or dy dx is equal to 2x over y. So how to separate the variable now? We're gonna have y dy is equal to 2x dx. Okay, and then integrate now. Can we integrate right away? So this is y squared over 2, right, guys? And then the antiderivative of 2x dx is just x squared. Do you get me? 2x squared over 2, so 2 cancels out. So this means x squared plus the constant. Can you now plug in the given condition that x equals 2 and y equals 1?
Oh shoot, yeah.
Or, but before that,
Oh, wait.
we can say, if we continue simplifying this one, I'll just simplify first, okay? So this is y squared is equal to 2 times x squared plus c. But do I have, when we distribute, do I have to put 2c?
No.
Not necessary. It's just c. Okay? So y squared is equal to 2x squared plus c. Remember, you don't have to write 2c. Okay? Because c is the constant. Any number, no matter what. So, what to do now? Take the square root, right? Take the square root. So, square root of, so y is equal to square root of 2x squared plus c. But this is plus and minus. Now, if we graph, what to consider? What will be our final answer? If we graph, it's gonna be y. Since y is positive, so we do square root of 2x squared plus c. But we need to identify what c is. You get me, guys? So what to do now? Plug in the value of x and y. Okay. Now, where to plug in? We can have it here, right? So y is 1. So that means the left side is 1/2. You get me, guys? So I'll just do it this right here. So that means 1 square over 2 is equal to 2 square plus c. You get me, guys? So which means this is 1/2 and then 4 plus c. So we have 1/2 minus 4 is equal to c. So therefore it's gonna be 8 over 2. So c therefore is negative 7/2. Okay, negative 7/2. Any question, guys? Clear? So you can now replace the c into negative 7/2 as the final answer. Any question? Okay. So again, put c right here, the value of c. Do I have to show it to you? Okay. That c is negative 7/2. So, yes,
Why don't we get rid of the plus or minus?
for this one, as I said a while ago, look at the value of y. What is y? Positive. So, do I have to put plus? No need. Only for minus, for negative. Clear, guys? And that's a good question. That's a good question. And I move now to number 3. Are you still copying, Diego?
No.
None.
Good, Diego? Yeah.
About melody, done? Okay. So we'll go to number 3. Of course, if you graph this one, you can graph, but take only the positive, right?
So we just, this is our answer right here. The radical. Yeah. So we don't have to draw anything here.
If you wish to draw, your concern is the up. What is the value? If x is 2, the function is 1, right? If x is 2, the function is 1 right here. Okay. If we graph that one, so that means 2, 1. This is the graph, right? Actually, the graph looks this way on top, and the bottom looks this way. Did you get me? if you use calculator, the graph should be right here. But because a while ago it was positive value, so we just have the positive, meaning the top. Okay? Gonna draw this way. This is our concern. Because of plus and minus, right? Plus and minus a while ago, but to graph this, we don't, since the condition right here that y, the f of 2 is equal to 1, that means positive value of y, right? Y is positive. So that is why the question of Chris a while ago, why is it that it's not plus and minus? It's just positive. Okay, so moving on to number 3. Unless you still have questions, I'm gonna entertain your question before we move on to number 3.
Thank you, Mr. Thank you.
Okay, no question, no pregunta. So let's move on to number 3. Okay, so this right here is the y, and this e to the x is for the dx, right? So we separate, but what is the initial condition? X equals 0, y is negative. So therefore, our concern is, what will be our final answer? That would be negative. Okay, if we graph. Okay, so we have dy dx.
Did we turn it 7.3 yesterday?
It's gonna be y plus 2 and then e to the power of x. So variable separable. So this gives us dy over y plus 2. Okay, and this is e to the power of x, then dx. So we separated already, right? So, and then after that, we're gonna do, and this can be rewritten as 1 over y plus 2 dy. So we can make use of natural logarithm, right? Okay, ln. And then this is equal to the integral of e to the power of x dx. So take the antiderivative. This is now ln y plus 2. Okay, so ln y plus 2, and then doesn't change, right? E to the power of x. So we have ln and then e to the power of x. So what to do?
We're missing the plus here, bro. We need to add this here, bro.
Can we now plug in plus c?
Yeah, plus.
Plus c. Can we now plug in the condition?
Oh, we can.
So can you do it? What is y? Negative 1, right?
Yeah.
So which means ln negative 1 plus 2, and then e to the power of 0, right? Is plus c. But what is right here? ln 1.
Isn't that like 0?
ln 1 is equal to, what is e to the power of 0? 1. Okay, plus c. But what is ln 1? Nada, right? 0. So we have 0 is equal to 1 plus c. Therefore, the constant is negative 1. And where to plug in that constant? Right here now, right? Okay. So we have ln y plus 2 is equal to e to the power of x minus 1. And then, is that our final answer? We're gonna simplify. What to do with that 2? So, we're gonna, but before that, what to do with that ln and e?
E. Then E to cancel it out.
So in order to eliminate ln, so we're gonna have to exponentiate.
Exponential. Yeah.
See me? We're gonna exponentiate both sides, right?
Yeah.
Exponentiate both sides. So exponentiate both sides. So exponentiating both sides like this now. So this is equivalent to this undo the ln, right? If we exponentiate. So we have y plus 2 is equal to e to the power of x minus 1. Okay. So what's next? What's next, guys? We are going to what?
Subtract
Subtract both sides by
2.
2. So we have y is equal to e to the power of x minus 1 minus 2. Okay? Now, if we graph, what is our concern? What is y?
Negative.
Negative. So that means your concern is the bottom, the negative. Okay? So you don't have to consider the top. It's just the bottom right here. If you graph. But as I said, that's not our concern this time. Because if we have this 0 and then negative 1, it must be right here, right? 0, negative 1. Am I right, guys? So the graph looks this way. This is the behavior of the graph. Goes that way until here. So we don't have to do the positive. We don't have to do the positive, okay? So this is now the final answer. So, shall we do practice now? We'll do practice.
This is ridiculous.
Can I move this up now, guys? Are you guys done?
This is what I'm done with. This is what I got left. Slap me. Why this reaction?
Almost done.
How was your trip? UCLA.
UCLA.
Was it good?
We won overall second for the National Engineering Design Competition. Second for I forgot. And then first place for moon base.
Okay.
The moon base entry. The contestants were Natalia Alvarez, and then Camila Calderon, and Natalia and London Lewis. And for the National Engineering Design, I forgot, sorry, Adeline. Shall we give Adeline a round of applause? So although Adeline wasn't there, but she's part of the team for the moon base. And then for the National Engineering Design Competition, it was Camela Calderon, Kevin Lopez, and Isaac Lopez.
Isaac Lopez?
Yes.
Isaac.
Mr. Roy, did they do the math one? The
No
math-
one.
No one.
Supposedly, it's you, right?
Oh,
The math escape. The math escape should be our entry is.
Come on.
Oh, really?
Oh, so what the hell, bro? What are you doing?
Did you do math escape?
Yeah, I couldn't go last.
So how was it? What was the problem all about for math escape?
May not be right
Really hard, confusing, and
That makes sense.
it was also not.
Time.
That was not about math.
Okay. But math escape competition is challenging.
Show. Show Mr. Roy in the picture.
Well, anyway,
That's big bird.
now. Because imagine we would have won.
okay, let's do practice now.
You know what time they came back?
Let's do practice.
5, I think.
Oh yeah.
So, given condition y equals 4 when x equals 0. Do we have enough time? How much time is left?
12 minutes.
12? Okay, we can do practice. So,
I turned that in.
so we say dy over y is equal to cosine x dx. So we separated now the variable, right? Or I can rewrite into the integral 1 over y dy is equal to the integral of cosine x dx. Remember, we are on antiderivative, so we go counterclockwise direction. So this is lny is equal to cosine is sine, okay? So sine x plus the constant. But what is the given condition? Y equals 4,
X is 0.
and then when x equals 0.
Can I give you?
So that means ln4 is equal to sine 0 plus constant. Now what is sine 0?
Oh, 1?
Are you sure?
Wait, no.
It is 0. Okay. So we have, and what is ln4?
I can't see.
But do we need to put it there?
Take pictures
What to do first? In order to get rid of natural logarithm, what we do before we plug in? Can I erase first this step?
Yeah.
Yeah, it's just for me.
Okay. Oops, sorry.
Oh, what we doing? Whoa. You wake up and hop on the game.
So we're gonna exponentiate both sides, right?
Yeah.
We're exponentiating both sides, so e and then e. So this means y is equal to e to the power of sine x plus the constant. And then we now plug in. Okay? Can you plug in now? Because what we are after is to solve for C. Okay? So, we have 4 is equal to e to the power of sine times 0 plus the constant. So how we write this now? Hmm?
You said 4 is equal to.
Okay, can you show it? Who wants to show it? Anybody? Now, look at this. Since this is absolute value, so we're gonna do plus and minus because it's absolute value. Again, the reason why we're gonna consider the positive or the negative depends on the y value, right? So this is gonna be plus and minus. Okay, plus and minus. Okay. So what's next, guys? How to write this now? 4. What to do with the constant?
Oh,
The front,
yeah.
then e to the power of sine 0. Okay? Or sine x. Okay? So, can you continue? So what do you think is our y right here? Our y is positive, right? Y is positive, so we just have the positive value. So we're gonna solve for C. Okay?
C for 4.
We're gonna solve for C. So we have 4 is equal to C times e to the power of 0. You get me? Here? But what is e to the power of 0? 1. So therefore, our C is 4. Where to plug in now? From here, right? Okay, so we say now y is equal to, we take the positive value since y is positive 4. So that means right here. So we have 4 e to the power of sine x. Okay? So y is equal to 4 times e to the power of sine x as our final answer.
Normally still comes for ranking now.
Yes.
Oh yeah, we placed third out of 56 schools.
See? Now remember,
Half of it, they're all from Southern Section.
so you mean this one?
LA City.
Now what is the law of exponent?
The first school.
Addition, that's the expanded form. Then what we do? We do compress. Addition turns to multiplication. So in that case, this is just the same as e to the power of sine x plus c, meaning e to the power of sine x times.
Like that one?
So if this is addition, on the law of exponent, this turns to multiplication. So this means e to the power of c. You get me? That's why we have this common base. Common base. The base is e. But what to do with this? Write this at the front. You get me? At the front, this one, power. So the C goes right here. Then sine X. But what is C defined? C is defined as 4. So this is 4 e to the
Sine of x.
sine x. Is this clear? And that is why, guys, that is why some Algebra 2 students were telling me, Mr. Roy, I'm gonna take
I got you.
pre-cal at Mission College during the summer. And I said, no, don't take pre-cal during summer in Mission College, because there are a lot of things you should learn in AP pre-cal prior to taking AP cal. Okay? So,
Oh, he said it was good. He said it was good.
I took it over the summer.
That's funny.